So we'll be talking more about just the beautiful stars we see in the nighttime sky and a little bit about how they came to be and how they're formed and what they're doing up there. But our sun is kind of a typical star. And what stars are all doing is, if they're alive or active, I know that stars don't actually live, but when a star gets warm enough, like we saw in the condensation theory of the formation of our sun and the planets, when a protosun in its nucleus gets hot enough to begin nuclear fusion and turns on, we say it becomes alive, is what I call nuclear fusion in its core, and that's what our sun is doing. So I want to take just kind of a quick look at kind of the structure of our sun. Our sun actually, or stars in general, okay, our sun, well, stars go through different phases, and our sun is actually in its kind of midlife where it's going to last a long time. We know it's been doing this for about 4.6 billion years, and it has about another 5 billion years to kind of do what it's doing, so we're in good shape. The center is the core. Outside the core, we have the radiation zone or radiative zone, and then we have the convection zone. So here we are. We have the core, and that's where it's the hottest. That is the hottest and most dense. That's where your nuclear fusion is going on. The radiative zone actually is where we talked about electromagnetic radiation, and radiative zone is where radiation actually is basically making energy kind of come out like that. And then we get to the convection zone, and if you're familiar with convection, and we'll talk about this in meteorology and a little bit in earth science, is convection is where hot things rise. So basically we have material that is coming from the radiative zone. It's rising up, and then it's cooling down as it rises, and it falls back down. So rising and falling. So we kind of create these little loops of material that are called convection loops, and that's the convection zone. And then beyond that, moving outward, we kind of think of the sun as having three outer layers then. The layer that is close to the convection zone. Now these to me would be more like gaseous layers. Okay, so going beyond the photosphere is a tough one, because to me it's kind of the Earth's surface, but it kind of, not Earth's surface, the sun's surface, and it kind of is moving out into the gaseous part. Photosphere, chromosphere, and corona. Okay, so those are going outwards. 1, 2, 3. Okay, going outwards. Up here actually is kind of a little bit of a tug of war we have going on with our sun, and I don't know if I really emphasize it in this course, but we talk about it when I teach astronomy. You kind of see the outward arrows. Okay, that's kind of the energy, kind of a positive pressure going out, and the green arrows is something that I think we may have talked about before, and that's the gravity. So we kind of have this outward going out, outward force from the energy going out, and inward force of gravity. Right now our sun's pretty stable, so that these are equal, the outward of the energy going out and the inward of gravity, and so our sun's not swelling or contracting, and so it's going to do that for generally about another 5 billion years or so. But here I can see I mentioned something about the solar wind. Oh, that's such a cool thing. The solar wind is actually a positive pressure going in all directions of the sun. Okay, and there's so many things you could say about the solar wind. Do you remember in the condensation theory, kind of between step number 4 and step number 5, basically when the sun turned on, all of the gas was kind of cleared from that had been forming the planets? Okay, that actually was clearing out, is the way I understand it, from the solar wind. All right. So some features on the sun. This is so cool. So this actually is a close-up of the sun, and can you kind of see these little they look like little honeycomb things. Those are actually called granules. The big thing right here is a sunspot. Okay, Now, sunspots kind of are cooler areas, and they're blemishes on the surface of the sun, and they're cooler areas that kind of rise and then they go away. Okay, so these are what we say transient. And granules are, if I could animate this, actually you would see the granules kind of wiggling and oozing. That is so cool. And both the granules and the sunspots are associated with kind of that lowest level of what we say the sun's atmosphere, the photosphere. And if you glance up at the sun, you are actually glancing up at the photosphere. So you've probably heard that sometimes we have some solar activity, and so I want to talk a little bit about that solar activity. These are some pictures of things that you might hear with regard to solar activity. The big granddaddy of them all, okay, is called a CME, stands for coronal mass ejection. Okay, coronal mass ejections are what hit the news when, and sometimes we don't necessarily know when these are going to happen, but basically that's a big blob, a big burp of the sun that can come potentially Earth's way and can play havoc with regard to electronics and electrical grids. Okay, now not quite so big, but also signs of an active sun. We have things like solar flares, which actually can cause some issues on Earth, and let's see, sunspots I mentioned. So here we kind of have some blemishes here, sunspots. Okay, so that's part of an active sun. Now, how do I say this? The activity of the sun actually is cyclical, and I don't know if you can see it right here. That's what I kind of brought in. Let's see what color would show up here. Okay, right here, you can kind of see going up and going down, going up and going down, and kind of the spikiness of it is showing you how many. Usually we just watch sunspots. So sunspots are an indication of the activity of the sun. So over here is how many sunspots there was. Over here is for a given year. So that's how that works. Oh, before I forget, my slide also says, it's just amazing that, we have spacecraft visiting Mars. We have spacecraft leaving the solar system. We have spacecraft that all they do, and it's an important thing, I don't mean to minimize it at all, but what they do is actually study and keep track at what the sun is doing. So I think that is so cool. So I wanted to mention this idea of, I guess, one last thing. So here is the solar cycle, okay, and it varies by 11 years. And actually, the reason reason we have a solar cycle has to do with the magnetic field of the sun, which I'm not necessarily going to get into. But if you're like me, you might be curious, well, what is the solar cycle doing now? So I have a website called spaceweather.com. That's where I generally go to. Now, this is a NASA site, but this is showing you what is the sun doing right now. So right here, this is where we're at in cycle number 24. I think it's 24 relative to the number of cycles since I just read recently 17-something, 1700s. So you can see where this is 2010, okay, 2013, 2015, 2016. So we actually are on a decline for kind of a going downward for our current solar cycle.